So next we shall discuss about the mechanism of action of phenytoin. Phenytoin blocks voltage gated sodium channels by selectively binding to the channel in the inactive state and slowing its rate of recovery. At very high concentration, phenytoin can also block voltage dependent sodium channels and interfere with the release of monoaminergic neurotransmitters. So basically what it says is phenytoin, the main mechanism of action of phenytoin is it will block the voltage gated sodium channels. And how it is blocking the voltage gated sodium channels? Yes, by binding to the channel when this voltage gated sodium channel is at inactive state, and it's slowing its rate of recovery. Means after inactive state, the voltage gated sodium channel will be flipping to the resting stage. So basically what this phenytoin is doing, it is increasing the time duration between inactive stage and resting stage. So basically it is increasing the refractory period. Okay, so let us first of all check out the normal physiology of epilepsy, and then we can understand how phenytoin treats epilepsy. So let us first of all check out the action potential of a neuron for better understanding. So this is a piece of neuronal membrane. You can see outside there is extracellular area and there is an intracellular area. This is mechanical gated sodium channel. This one is voltage gated sodium channel. This one is calcium channel and this one is a potassium channel. Now this neuronal membrane has got a potential. When the membrane is inactive, it is known as the resting membrane potential. Okay, so at resting condition, when there is no activity, when there is no exchange of ions, cations or anions, this membrane is at a resting condition. At a resting condition, it will be having a potential known as the resting membrane potential. Okay, so a resting membrane potential, it is maintained at minus 70 millivolt. Okay, now whenever stimulated, sodium enters via the mechanical gated sodium channel. Okay, so via this mechanical gated sodium channel, the sodium will be entering inside whenever this neuronal membrane is stimulated. Now whenever a cation has been moved inside, that means positive charges are been moving inside. So what will happen to the potential of the membrane? Yes, it will move to more positive side. So instead of minus 70 millivolt, now the membrane potential has been moved to minus 60 millivolt. And suppose minus 60 millivolt is the threshold potential. Okay, so stimulation of voltage gated sodium channel will be taking place. So whenever threshold potential has been attained, it will cause activation of the voltage gated sodium channel. Now few words regarding this voltage gated sodium channel. So this is a voltage gated sodium channel and it has got two important gates. This one is activation gate and this one is inactivation gate, and both are connected via a chain. Okay, so whenever activation gate is closed, inactivation gate will be open. Okay, and whenever activation gates are open, this chain will pull the inactivation gate to close. And whenever inactivation gate is open, same chain will pull the activation gate to close. Okay, so one gate is open, then another gate should be closed. Okay, now what causes opening and closing of gates of the voltage gated sodium channels? That is changes in voltage. Now, depending upon voltage, the voltage gated sodium channels exist in three conformation. They are resting conformation, active conformation and inactive conformation. At resting conformation, activation gates are closed and inactivation gate is open. At active conformation, both activation as well as inactivation gates are open, and this will offer transportation of the sodium ions. Next, in inactivation conformation, activation gate is open, inactivation gate is closed, and this will hinder the transportation of sodium ions. So, we have got a resting conformation in which activation gate is closed, inactivation gate is open. After resting conformation, this voltage gated sodium channel will be flipping to active conformation, where both activation and inactivation gates are open for a brief duration of time. And after active conformation, the voltage gated sodium channel will be flipping to inactive conformation, where the activation gates are open but inactivation gates are closed. And after inactive conformation, again this voltage gated sodium channel will be flipping to resting stage. Okay, resting, active, inactive, then after inactive again resting, then active, then inactive. Okay, next, coming back to our story, we have this a resting membrane potential of minus 70 millivolt. Okay, this is a resting conformation. At resting membrane potential, the voltage gated sodium channel will be at resting conformation. Resting conformation means activation gates are closed, inactivation gates are open. Okay, now whenever we stimulate this membrane, what will happen? Sodium ion will gain entry via this mechanical gated sodium channel. Okay, now when positive charges moves inside, the membrane potential from minus 70 millivolt will be moving to more positive side, that is minus 60 millivolt, and that is the threshold potential. And once threshold potential is attained, what will happen? It will flip the resting conformation into the active conformation. So at active conformation, what will happen? Both activation and inactivation gates are open, and it will cause influx of large number of sodium ions. Now when huge amount of sodium ions have been moved inside, then what will happen to the potential of the membrane? Yes, it will move to more positive side, like to plus 10 millivolt. Now this membrane potential, which was initially negatively charged, has become now positive charges. So changes in the charges has been taking place. This condition is known as depolarization. And once depolarization has been attained, what will happen? Again there is changes in the polarity, isn't it? Because of depolarization, this voltage gated sodium channel, it will flip to inactive conformation. Now inactive conformation means activation gates are open but inactivation gates will be closed, and it will hinder the influx of sodium ion. Okay, so no more influx of sodium ion, so the potential will no more move to more positive side. Now this depolarization has caused inactivation of the voltage gated sodium channel, but there will be activation of this potassium channel, and via potassium channel there will be outflux of potassium ion, that means loss of positive charges. When there is loss of in positive charges, then what will happen to the polarity of the membrane? Yes, it will be moving to more negative side. So the membrane which was initially negatively charged has flipped to positive charges and then again back to negative charge. So this condition is known as repolarization. Okay, so there was a resting condition, then depolarization followed by repolarization. Okay, so you can see over here the resting membrane potential is minus 70 millivolt. Once it was stimulated, so because of stimulation via the mechanically gated sodium channel, sodium influx was took place, because of which threshold potential was been attained. So until here the conformation of the voltage gated sodium channel was resting conformation. Now once threshold potential was attained, what will happen? It will cause opening of the voltage gated sodium channel, because of which depolarization happened. Okay, so during depolarization the voltage gated sodium channel was at active conformation, and once depolarization has been took place, then what will happen next? It will cause inactivation of the voltage gated sodium channel, because of which repolarization happened. Okay, so this wave of depolarization followed by repolarization, this is known as action potential. Okay, now what happens during epilepsy? In during epilepsy, the frequency of action potential is increased. Okay, now suppose this is the action potential of normal individual and this is action potential during epilepsy. Now during normal action potential, what will happen? Yes, there will be some no frequency for action potential to be taking place. Okay, this is action potential of normal individual. Now you compare it with the action potential during epilepsy. You can see the frequency of action potential. Yes, the duration of action potential is very much short, and the number of action potential is very much high, isn't it? Now if we like to count the number of action potential you check out, okay, the same duration, maybe the time duration is 1 minute. So in 1 minute, in a normal individual, the action potential happened 7 times, but for a person suffering from epilepsy, the action potential happened nearly 12 times, almost double, you can say. So during epilepsy, the frequency of action potential is very much increased, isn't it? What's I've written. So in epilepsy, the frequency of action potential is increased. And Phenytoin treats epilepsy by reducing the action potential frequency. Okay, so what this Phenytoin is doing, yes, what we read in the initial in the first slide, the Phenytoin, it will block the voltage gated sodium channel when it is in inactive stage. Okay, so this is the normal action potential or action potential of the epileptic person, and phenytoin will increase the duration of inactive conformation of the voltage gated sodium channel. So what will happen? Yes, it will take a huge time for repolarization. So initially it was like here normally the inactive stage completed, but what will happen when we give phenytoin? It will increase the time duration for inactive stage. Okay, so for such a long time the voltage gated sodium channel was maintained in the inactive conformation. Okay, so this is the duration of one action potential, and this is also the duration of one action potential, but the duration is prolonged because of phenytoin. So basically what phenytoin is doing, it is blocking the voltage gated sodium channel by binding it at the inactive conformation, and it is increasing the time to flip the inactive conformation into the resting condition. So basically it is increasing the duration of action potential. Okay, so phenytoin, it increases the refractory period, and this is what the action potential of phenytoin is.